This is the final presentation of Group A of the Velomobile. And my name is Tuomas Lahtinen.
Είμαι ο Κωνσταντίνος Μπούνος.
Nazywam się Mateusz Sadowski.
Ik ben Jan de Wolf.
Meu nome é Pedro Pinto.
Eu sou Donatas Balchunas.
The objectives of this project are tire properties and rolling resistance, steering systems, suspension systems, braking systems, electrical drivetrain, material and component selection, and mechanical drivetrain.
So next part will be the braking system. The main functions of our braking systems are to slow down our vehicle, to bring our vehicle to a halt, to prevent the moving of our vehicle. How will this be achieved? By means of two front and one back brake discs, which are perforated for optimal heat dispersion. A brake lever, which delivers the braking pressure. Brake lines, especially optimized for as little expansion as possible. 3 brake calipers, which delivers the pushing power to the brake pads. How did we decide from which brand we would buy our parts? Very simple. We made a decision chart and entered all the most significant factors to us. Then we awarded points for each brand. The brand with the most points, that's where we buy our parts from. Some specs of our braking kits are organic brake pads with greater price-quality ratio, a good-rich hose kit which is developed with Formula 1 technology for optimal braking, a lightweight rear caliper with a supposed 2-piston design for optimal pad wear and the best braking performance possible.
Group A decided to choose 20-inch wheels in front of the vehicle because of the optimal properties offered in this tire class for the zero-emission human-powered vehicle. Size of the rear wheel is 26 inches and it's defined by the electric motor located in the wheel. To the rear, we have chosen a tire that has the maximum width offered in the bicycle tire range and has quite smooth surface to minimize rolling resistance. We want the rear tire to be as wide as possible because the designed zero-emission human-powered vehicle is rated at 150 kilograms of vehicle mass. This means that the designed vehicle is much heavier than a regular bicycle. A wide tire can carry the mass better than a regular tire, also considering the torque delivered to the rear tire by the electric motor mounted in the rear wheel.
So about the hub motor and the battery pack and all the electronics, we've decided to go with Pepper Motors because it has the best package and the best performance and price ratio. About the motor, it has a direct drive hub motor with 1k watts of standard power and 1500 watts of peak power. It weighs about 7 kilograms. The battery, it has a voltage of 48 volts. The capacity is 15 amps an hour. Its weight is about 7 kilos and a half. As you can see in the chart, when he has his normal output power, 1k watts, it has a top speed of 55 kilometers an hour and a range of 45 kilometers.
Now, about the suspension system. For the rear shock, we have chosen the Vanilla model from the Fox company. It is a bolt-on coilover suspension which fits to the rear strut mechanism. We have decided to use this model because it is fully adjustable. So we can adjust the preload, the rebound parameters, and also the coil thickness to improve our velomobile dynamics. Also, we can change the parameters for racing or a normal setup. About the front suspension. We have chosen the Mani 2-meter coil shock, which has the same adjusting characteristics as the Fox one, providing a better price. About the aerodynamic cell. We need a low aerodynamic coefficient, an attractive shape, and a low-cost construction. How can we achieve this? Our crew decided to buy the components and rely on a professional's experience to manufacture it for us. This fiberglass kit is the best value for money feature for aerocell design. It is apart from a Mi50 catalyst, 45 grams of matting, 1 barrel roller, 2 brushes, and a pair of protecting handled gloves. Now, about the chassis. We wanted to have a strong, safe, foldable, and lightweight construction. For the reasons above, we have decided to use an aluminum frame. We have thought to buy aluminum tubes of 40 and 25 millimeters and construct the frame by ourselves, rather than buy it from a company. So, we will save money from the total cost.
Now we will talk about mechanical parts. In this case we have one rear and two front wheels and aluminum frame. I choose a chain, pedals, front and rear net and front chain set. We don't need rear chain set because it is a part of a hub motor. We choose to use Shimano and Velgo brand because it has the best price and quality data compared with all manufacturers. Chain, we think it's one of the most important parts because it transmits leg force to rear wheel. We need about 3 meters of chain, therefore we decided to use 3 chains, maybe 4, which we tend to combine in series with contactors. Second mechanical parts, what we need is pedal. We must be very comfortable for passengers and easy to pedal. Second part is front chain set. As I mentioned previously, we don't need rear chain set. We need front chain set with 3 chain rings, and we think one of the most important specification of chain set is smooth, passive shifting and good power transfer to rear wheel. And the last part of mechanical systems are rear and front match. We decided that our automobile must have 27 gears, and here you can see our parts.
What can we tell about steering system? The control system must be designed. All parts must be matched to our vehicle. We need to do the steering rods. They must be complete with the requirements of the resistance and durability. Steering control should be made from the aluminum tube. This will be reduce of cost of projects, and aluminum reduce case weight. This is important to the control system are user-friendly. The design should be based on the system that is used in the ice trucks automobiles. And by matching, cutting, welding and bolting, we can make all of these parts. Chassis core, wishbone control arms, steering brackets, tire rods. Seat can be ordered from the ice trucks company. Seat is comfortable, ergonomic and lightweighted. Have side support from the corners and the extra bag for the staff. It costs only $100. The grade of the value fluency.
So, and with a lot of hard work, we were trying to accomplish this kind of model of automobile with an aeroshell for racing. And with this kind of budget, and a total components amount of about $2,463, and with 40 hours of labor and a total cost of $1,600, we can have a total cost and a budget of roughly $4,000. Thank you for your attention. This is the end of Group A presentation.